let's record this. All right. So Megan, what was your question?
So I trying to identify what the tangent point is.
Yes.
So initially I was wondering, is the tangent point like a comparison point, or is it a specific point on the graph?
So we are talking about now finding the best optimal level of labor and capital combination to produce certain level of output. So let's say I want to produce this. This is an isoquant. Okay, on this line, let's pick a different color. Let's make it different than the graph, the axis. So this is Q. Okay, this is an isoquant, the blue one. And on all points on this isoquant, you are producing the same level of output. Let's assume there's a star here. So it's the optimal level of output. We will learn about this in chapter 12. So assume that this is the optimal level of output. And let's say I want to produce 200 units per day, 200 pickup trucks per day. Okay. So Megan, is this, what's the significance between this and the the intersection of this isoquant? And we're looking, what we're doing is to find capital and labor combos that produces the lowest cost to produce what? To produce this quantity. So I'm trying to find capital and labor combination that produces the lowest cost. So then we have, right, isocost curves. That was really crooked. Then we have isocost curves. So isocost curves in the same plane, right, capital labor. Isocost curves will give you the lowest, the equal cost of producing certain different levels of output. Okay, so on an isocost curve, and there's an infinite number of isocost curves here. So the slope of this is general information. I'm almost teaching from zero. I always tell myself I'm not going to teach in office hours, but I just feel like we have to negative W over R. What is W? W is price of labor, and R is the price of capital, rental rate of capital. Okay, so there's a negative sign because it's downward sloping, but in absolute value is W over R. And we have intercepts here. So this is, imagine this is C1 isocost curve. We call it C1. Let's call this C0. Let's call this C2. So all these, as you move away from the origin, the cost of production goes up. Okay. So for instance, what do we know about intercepts? This intercept is going to be C0 over W. So what's the total cost of production? Let's say $1,000. This isocost curve is costing you $1,000. If I use only labor, each labor is $100. 1,000 divided by 100, you can hire 10 maximum workers. That's what it means. C1 over W. And then this intercept is C2 over W, okay? So I just want to write down the formula again of an isocost, cost of one labor times number of workers I hired plus cost of capital per unit times number of capital I hired equals to some C total cost of production. It's the general formula. If I pull K by itself, so these are the things that we learned in, videos. 1 over R C minus W over R L. I ended up teaching everything, but it's okay because we need to build it up. So I have not millions, infinite number of cost curves in this plane. So I'm trying to find the least cost away. For instance, let me ask you, let's say this is C1. This is C0. Can I produce 200 units by only spending this much? So can I produce 200 units? I'm asking you a question. You can unmute yourself. Can I reach to, yes, Megan?
I missed something.
No,
Yeah,
it's okay. So
okay,
the question is,
Yes.
Can I produce 200 units by only trying to spend $0?
You wouldn't be able to produce 200 because it's below
Yeah,
the isoquant line.
yes. So how about this one? Like, see, this is too high, right? C5
Yes,
or
like you
something.
could produce 200, but it would cost you way too much.
Yeah, so you could maybe, if this is exactly, so let's say this thing goes down right here, just like in this situation, look, I'm trying to produce this level, 800 units in this question. Okay, I'm trying to produce this. The least costly way to produce it is this point where my isoquant is tangent to this isocost. If I try to produce, you can do it, Q, by using this level of cost, right? Now I'm actually on this isocost curve. I'm just wasting my resources. So it's like university trying to teach this class. So this is what happened. I could actually hire two very qualified graders for this class. But I said, I don't need it, okay? So I can handle this class by myself. I don't need graders. So it's like if I requested 2 graders or whatever the university gives me, right? University is spending more money necessary. So we're higher ISO cost curve to produce this 800, right? The blue line, instead of going to the least costly way of producing it, we're just going to an isocost that's here, which is wasting money. Same thing with this C5. So what I'm doing, what I'm trying to do is actually finding exactly what you asked.
I think too, while you're drawing that, I think, and tell me if I'm understanding, oh, what's that? If I'm understanding or not understanding, that's my alarm. So at point B,
Yes,
it's not an optimal choice
yes.
because my marginal product of labor is what is it? It would be higher. So for less labor, I can produce more. I mean, for less cost, I can produce more.
So I like
Am I
how
going
you
backwards?
jumped to that. Okay, so exactly. So here at point C, okay, I'm just going to write this down. This is really important. And in the videos, I explain this. Excuse me. So slope, this is great time to, insert some general information.
I think because number 14, I know I didn't go watch that part of the video yet. I haven't got, because
That's
towards the
fine.
end.
I mean, we can
but-
always, yeah.
Well, I think that's where I was getting mixed up because I wasn't understanding the difference in I'm trying to think of how to say it. I know in the book they called it the best bang for your buck is the phrase. Yeah. So
It's nothing.
yeah. So that's why I was like, I don't understand. I didn't figure it out on because 14 and 15, they look like the exact same questions, but
Yes.
the points are different. So I can make more with less labor versus I can make more with less capital, or whichever one it was.
Yes, so we're going to now go over stuff. So slope of isoquant, these are -2. Marginal rate of technical substitution is the positive of it. It's okay. We just covered those negative signs. So let's take a look. I'm just going to pick some points. So let's say this is capital. Always label stuff. And this is, okay, let's just move it here. This point C, okay? So I want to pick a different color actually, so that isoquant and isocost don't get mixed up. Okay, this point C, and let's pick another point and also another point, okay? So A and B, okay? So different points. So we're gonna cover everything in this video basically. So slope of isocost. I wish I color coded it. So isocost, slope of isocost, all these blue lines, this one and the other one, this one, they all have the same slope. They have to, of Okay, so at point C, at C, that's an at sign at C, what you have is marginal product, margin rate of technical substitution, okay, is exactly equal to the rental rate ratio. And what we did here, this is what you're asking. Was it you, Megan, who asked, or Kate? Doesn't matter.
Yeah.
So we're going to exchange the places of these two, okay? I'm going to move wage to the denominator, left-hand side, move marginal product of capital to the numerator of the right-hand side. You can do that in inequality. So at point C, marginal product of labor divided by wage rate is equal to marginal product of capital divided by rental rate. So the most important thing is to know the translation of this to English, okay? So let's say labor produces, each worker produces 20 and each worker is paid $5, okay? So what you find is going to be 4 units. So if you divide 20 by 5, 4 units per dollar spent on labor. Okay, so let's say on the other hand, marginal product of capital is, I'm making up numbers, 100, but the price of capital rental rate is $25. Okay, that's fine. So again, 100 divided by 25, it's again 4 units of output that we get, quantity, per 4 units of output per dollar spent on capital. So we're trying to find this equality. Once they're equal to each other, we are now producing optimal, with the optimal level of combination of labor and capital, which is here. I'm going to mark it L star and K star. So where did this isoquant came from? Q star. I don't know. This isoquant comes from chapter 12. We're going to learn about it in chapter 12. And warning, chapter 12 looks even more complicated, but it is not. Not everything will be in the test, and I'll make sure that I'm already working on chapter 10, which is the unit 6. I'm already working on questions solved. So if you finish this chapter, right, move on to chapter 10 immediately. And then I'm going to solve questions for 12 so that you'll feel confident. Okay, I got this. Anyways, going back. So in English, I am spending $1 on labor versus capital. If they're equal to each other, I achieve the best combination. But what if this is the case? What if somehow marginal product of labor divided by wage rate, that means each dollar spent on labor brings me more output than each dollar I spend on capital. So which one should I employ more?
I think I got mixed up on some of your words, but I think that if I heard you right, if I spend less money and get more output on labor, then I should increase my labor.
Yeah, so it's not less money. You're spending $1 on each.
Oh, you spend this. Okay, so you spend the same money, but I gain more output from labor. Yeah. So I should increase my labor use.
Exactly. That's exactly what we do, because that will decrease my marginal product of labor. As you hire more labor, marginal product will go down. So hopefully we'll reach to equality in the future. Okay. So if this is the case, let's say so this happens. Okay. When does this happen? This happens. So this happens if the, right here at point A, okay, right here, what's happening here? The slope of my isoquant, this guy, okay, so this green one, slope of this, I'm just decluttering it. The slope of my isoquant Q star right here, look at this, it's steeper than my isocos slope. Isocos slope is, we can find the steeper the slope is, the higher the slope, the steeper the curve, the higher the slope in absolute value. So the slope of my quant pretty steep here. Okay. So what was the slope of the isoquant? Marginal product of labor divided by marginal product of capital. Actually greater than at point A, greater than the wage and rental rate ratio. So if you rearrange, you're gonna get marginal product of labor divided by wage rate. Oops, greater than. So that's what you were saying, getting more bang for your buck.
Yes.
Not very, not the technical way we use, but that's
Right.
exactly what's going
I
on.
think it was one of the things they quote early in the chapter that was like, here is the quote you might have heard, but here's what it actually means.
Yes.
Yeah.
So it is, I mean, yeah, this is correct. Look, this means in English, I spent $1 on. Okay, no problem, no problem. So I spent $1 on labor, and this is the output, which is greater than when I spent $1 on capital. So in this case, you have to increase your labor and you have to drop your capital if you can. Okay. So another one, let's look at another point. The other point is, let's pick plum color. So point B, look at point B. At point B, at B, something different is going on. The slope of this is my isoquant. Slope of my isoquant is flatter at point B compared to this dark blue line, which is my isocost. So at point B, the slope of isoquant, of course, this is the absolute value, so, okay, is less than the slope of the budget line, which is the blue, this one, is less than. How do I know it's less than? Look, this is flatter, this is steeper. Do you see it? Here, my isoquant slope right at this point is exactly equal to the slope of the budget line. So in this case, again, rearranging. Oh no, what happened? So marginal product of labor divided by wage rate is less than the product of capital divided by rental rate. In English translation, I spent $1 capital and it gave me more output than when I spend $1 on labor. So why should I spend more time on more money on labor? So I have to hire more capital in this case. Does it make sense? Is it a little better?
Yes, this is much better.
Thankfully.
Yeah, this is
so
good.
Look at my solutions. Let me stop recording because we may share something, Okay, I stopped recording.